Everybody, in this video, we're going to go over the review sheet for the last test of the semester, test number 6. So for number 1, what I'm going to do is I'm going to draw a picture. I'm going to draw parallelogram WXYZ. Quadrilateral WXYZ. And our goal is to find the answer choice that does not prove it's a parallelogram. So I'm going to go answer choice by answer choice and just test out the information. Oops. So I'm going to start with the last answer choice for this one. So WX is parallel to ZY, and WX is congruent to ZY. This does prove that we have a parallelogram. Remember, we have a theorem that says if one pair of opposite sides is both parallel and congruent, then the quadrilateral is a parallelogram. So let me reset. Answer choice 4 does prove parallelogram, so it's not correct. And let me move up to number 3. WX congruent to YZ and XY congruent to WZ. Both pairs of opposite sides are congruent, so this is a parallelogram. So once again, not the answer choice that we are looking for. WY and XZ bisect each other. If diagonals bisect each other, then we do have a parallelogram. That is one of our properties of parallelograms. So once again, this does prove parallelogram, not the answer we're looking for. And finally, WX is parallel to YZ, and WZ is congruent to XY. This is not one pair of opposite sides that are both congruent and parallel. This is one pair parallel and a different pair congruent. That doesn't prove we have a parallelogram. It needs to be both pairs parallel, or both pairs congruent, or one pair that is both congruent and parallel. We have found our correct answer choice. Always draw a picture. Always try out the answer choices in your diagram. Which of the following conditions does not completely specify that a figure is a square? It is a rhombus that has congruent diagonals. Well, to be a square, it needs to have both properties of a rectangle and a rhombus. Number 1 mentions that it's already a rhombus, so now we're just looking for a rectangle property to make it a square. And congruent diagonals is a rectangle property, so this is a square. Not the answer choice we're looking for. It says does not specify that we have a square. It is a rectangle. Okay, so that's halfway there. Now we just need to know it's also a rhombus that has perpendicular diagonals. Perpendicular diagonals is a rhombus property. So this is a square. It's both a rectangle with a rhombus property. So a rectangle and a rhombus. Once again, not the answer we're looking for. It is a parallelogram whose diagonals perpendicularly bisect each other. So it's already a parallelogram, but to be a square, it also needs to be a rectangle and a rhombus. Diagonals being perpendicular, that's a rhombus property, just like we said in number 2, but we're still looking for the rectangle property. Diagonals bisecting each other, that's a parallelogram property, but it's already a parallelogram. So even though we know it's a parallelogram and a rhombus, we're missing a property here that would make it a rectangle, so we don't know it's a square. Remember, in order to be a square, it needs to be both a rhombus and a rectangle. And now let's check out why number 4 is not the correct answer. It's a parallelogram. Okay, so we still need rectangle and rhombus with at least one right angle. Oh, we know that a parallelogram with a right angle is a rectangle. That means all the angles are right angles. So we got the rectangle property. And at least one pair of adjacent sides that are congruent. We know that if we have a parallelogram that has congruent adjacent or congruent consecutive sides, it's a rhombus. That implies all the sides are equal, making it equilateral. So in number 4, we do have a rectangle property and a rhombus property. So we do know it's a square. So that's why 4 is not the right answer. We were looking for the choice that does not make it a square. That's not both rhombus and rectangle. Okay, we know that the measure of angle BAC in this rectangle is 3x plus 4. And we know that the measure of angle ACD is x plus 28. What is, oh no, it seemed to have changed languages here. That's weird. Okay, that's what happens when I convert it to different formats. What is the measure of angle ACB? So we are looking for, let me put a question mark. Oops. For this angle right here. Well, I know that a rectangle has 90-degree angles. So I know that altogether this angle needs to make 90 degrees. I can find what this piece is. Then I can subtract from 90 and get the one I'm looking for. The thing is, I have to first find x. So I see that there's x in this angle and x in this angle. So I'm going to think about the relationship between this angle and this angle. If I get my highlighter out for a second, just want to highlight the lines forming those angles and the transversal that intersects them. Notice that we have a backwards letter Z. In the corner of the Z are alternate interior angles. And since it's a rectangle, we do know that opposite sides are parallel, just like a parallelogram. We do have parallel lines cut by a transversal. When parallel lines are cut by a transversal, alternate interior angles are congruent. So I can make the equation 3x plus 4 is equal to x plus 28. If we really quickly solve this, 2x is equal to 24. X is equal to 12. We get our x value. Plugging in, B8 plus 12, that's 40 degrees. So that means the other part of the 90-degree angle has to be 50 degrees to make the 90-degree angle. Here we have parallelogram PQRS, and we're told that ST is congruent to SP, and that angle R is 130 degrees. Since I know PQRS is a parallelogram, and we're talking about the angles, I'm going to think about my angle properties of parallelogram. Remember that in a parallelogram, the opposite angles are congruent. So if angle R is 130, that means angle P also has to be 130 degrees. And then I'm going to think about my given information because all my givens are there for a reason. They told me that SP is congruent to ST. SP and ST are sides of triangle SPT. So I know triangle SPT is isosceles. It has two congruent sides. And remember, when a triangle has two equal sides, the angles opposite the congruent sides are also congruent. So I know that these two angles in the triangle also need to be congruent. I know that the 130-degree angle and the angle right next to it in the triangle are a linear pair. They're supplementary. So if this is 130, 180 minus 130 is 50. So that means this angle is also 50. 50 plus 50 is 100. So that means the last angle in the triangle to make 180 degrees is 80, and that's the angle that we're looking for. That's angle PST. Here we have isosceles trapezoid, QRST. And it says that QR and TS are the bases. So already I'm going to fill in what I know. Parallel, congruent sides. Since it's an isosceles trapezoid, I also know the base angles are congruent. And I think that property is going to be important here because they're giving me angle measurements in the givens. So angle Q, I'm just going to put an arrow. I can't fit that inside. Is 5x plus 3. And if angle Q is 5x plus 3, that means angle R can also be represented as 5x plus 3 because the base angles are congruent in an isosceles trapezoid. Oh, they give me another measurement for angle R. Never mind. Angle R is 7x minus 15. But since we just said base angles are congruent in an isosceles trapezoid, we can just make an equation that says angle Q, which is 5x plus 3, has to be equal to angle R, which is 7x minus 15. Subtracting 5x from both sides, adding 15 to both sides, I have 18 is equal to 2x. Now all we need to do is divide by 2, and I get x is equal to 9. Plugging in for angle Q, because that's what we're looking for, 5 times 9 plus 3, and that is 48 degrees. Here we have trapezoid trap with median MQ. So that means that M and Q are midpoints. So this is the mid segment of the trapezoid, the mid segment. And we need to find X and Y. So anytime we have any trapezoid, because we don't know this is isosceles here. So anytime we have any trapezoid, the only thing we really know about the trapezoid, unless it's also isosceles, is that the bases are parallel. Oops. And remember, if the bases are parallel, since we have parallel lines cut by a transversal, the upper base angle and the lower base angle directly below it are same side interior angles, so they're supplementary to each other. Inside the lines, both to the right of the transversal. So I can set up an equation that says 12x minus 4 plus 7x plus 13 is equal to 180. So that is 19x plus 9 is equal to 180 degrees. And keep in mind, anytime you have any trapezoid, the upper base angle and the lower base angle directly below it will always be supplementary because they'll always be same side interior angles. Okay, subtracting 9 from both sides, I have 19x is equal to 171. Dividing by 19, I have x is equal to 9. Okay, now solving for y. So y is in the lengths of the sides, not the angles like x was. So we have a midsegment, and I know that the midsegment of a trapezoid is the average of the bases, or half the sum of the bases. So I'm going to make an equation that says if I take base 1 and base 2, and I add them together and divide them by 2, if I average them, I should get the midsegment. Combine my like terms really quick. So that's 12 plus 18, which is 30, plus 7 over 2 is equal to 16y plus 1. What I'm going to do now is I'm going to multiply both sides by 2. Make sure when you multiply this side by 2 that you distribute the 2 to everything inside the parentheses. So here we have 30y plus 7 is equal to 32y plus 2. Subtracting 30 from both sides, subtracting 2 from both sides, I have 5 is equal to 2y. And then 5 divided by 2, because I'm going to divide 2 by both sides, tells me that y is equal to 2.5. Okay. Remember, midsegment of a trapezoid is half the sum of the bases. It's the average of the bases. Okay, here we have a coordinate proof. So 1, 1, 2, 3, 4, 5. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. Part A says to prove that this quadrilateral is a trapezoid. So I know by definition, a trapezoid has only one pair of parallel sides. I'm just going to use slope formula to show that only the bases are parallel to each other. So I'm going to pause the video so I can plug into my slope formula. So here are my slope formulas so that you can check them with yours. And notice how I ended with a concluding statement. Since only one pair of opposite sides are parallel, quadrilateral K is a trapezoid. Your concluding statement should summarize what your calculations show and how you know that. So basically what you're proving and how that you know that you proved it. For part B, we need to prove that K is not an isosceles trapezoid. So there's two options. If it was an isosceles trapezoid, it would have congruent legs. So you can find the length of KE and AT using the distance formula, and you can see that they're not congruent. That's what I'm going to do. Another option, since isosceles trapezoids do have congruent diagonals, is you could find the length using distance formula of KT and AE, and you can see that those are not congruent. I'm going to do the legs, so I'm going to do KE and AT. I'm going to pause the video so I can plug into my distance formula. Okay, here are my calculations to find the length of the legs so that you can match them up with your own. And I ended with a concluding statement. Since the legs are not congruent, trapezoid K is not isosceles. Moving on. Okay, so here we have parallelogram FLSH. So the whole entire quadrilateral is a parallelogram. And we know that we have some perpendicular lines, and in the diagram, they already put those right angles in for us. When we get to our proof, we're going to have to put the right angles into our proof, but they're already marked in the diagram for us. Once again, my proof statement went missing, so let me double check on the original document to see what it was. So let me go down over here. FA congruent to SG. So FA congruent to SG. So often in times and proofs, it works better to work backwards, because if I just start marking everything that I remember about parallelograms, I'm going to have a really confusing diagram with a lot of stuff marked that might be true, but may not be helpful for me in reaching my goal. So I might get confused by over marking my diagram with stuff that I don't even know if it's important. So I'm going to work backwards. I'm going to take a look at my proof statement, and I'm going to try to figure out what I'm focusing on. I also noticed that inside the parallelogram, there's triangles. So I want to figure out which triangles I'm going to be focusing on. And often in quadrilateral proofs, it comes down to proving two triangles congruent, as we've seen in class many times. So I'm looking for two triangles. One triangle should have FA as a side, and one triangle should have SG as a side, because those are the two triangles that I'm trying to prove congruent. Those are the two sides, the two line segments that I'm trying to prove congruent. So here is FA, and I see that FA is a side of this triangle here. And SG right over here, and I see that it's a side of this triangle here. So if I can prove these two triangles congruent, then using CP/CPC, I can say that FA and SG are also congruent because they're sides of these two triangles. So that's kind of my plan. So now that I know that the two triangles I'm focusing on, now I can think about which properties of parallelograms would give me information inside of these two triangles, because that's what I'm interested in. So the first thing I think about is opposite sides of a parallelogram. Opposite sides are congruent, and that would give me LS congruent to FH. So that would be super helpful, because that's a side of each of the two triangles. I also already have the right angle, so that's a congruent angle that I can use. So I need either another angle or another side. If I get another side, maybe I can use HL. If I get another angle, maybe I can use AAS. It depends on what I can get. Let me think about more properties of parallelograms. Ooh, opposite sides are also parallel. That could help me get angles, because whenever we have parallel lines, we can think parallel lines cut by a transversal, and that could help us get angle relationships. So parallel lines are super helpful in figuring out angles if you want to look for angles. So parallel lines cut by a transversal, and guess what? I see that letter Z. So I know that in the corner of my letter Z are those congruent alternate interior angles. Since I have parallel lines cut by a transversal, the alternate interior angles are congruent. And now I see I have enough information to prove the triangle's congruent by angle, angle, side. Angle, angle, side. So AAS is the route I'm going to take. And after that, it's one more step using CPCTC to prove FA congruent to SG. Now that we have our whole entire plan and we know exactly what's going to go in our proof, we're sure not to put just like unnecessary information into our proof that's not going to help us achieve our goal. And all I have to do now is transfer all the stuff that we marked in the proof, in the diagram, into the actual proof. Remember, you only get points based on what you have in the actual proof on the Regents exam. Marking the diagram is for you, but what's counted is what's in the proof. So I'm going to pause the video so I can just write up what we marked in the diagram. Okay, here's the proof completely written up. It starts here, steps 1 through 4, and then it's finished up here, steps 5 through 8. Please pause the video so that way you can read through it at your own pace and you can make sure that you match up everything in the proof to what's in your own proof or what's in the diagram already marked. So make sure you pause the video because I'm going to click over to the next slide. Okay, so here we have another coordinate proof. Let me just make sure there was nothing else here. Yes, there was. There was another proof. Okay, so we have isosceles triangle trapezoid ABCD, and the bases are DC and AB, and the non-parallel legs are AD and BC. We know that angle CDE is congruent to angle DCE. We know that AE is perpendicular to DE, and we know that BE is perpendicular to CE. We need to prove that triangle ADE is congruent to triangle BCE, first of all. That's not too bad. We know this is an isosceles trapezoid, so I know that the legs are congruent. And I also have a triangle up here with 2 equal angles. And I know if a triangle has 2 equal angles, the sides opposite those angles are also congruent. So now take a look at what I have. I don't have side angle side because the angle is not directly in between the two sides. It's side angle side, or SSA, which is a bad word spelled backwards. So it's not valid. But what we do have are right triangles, congruent hypotenuses, and congruent legs. So what I do have here is HL. Not the only method. Some of you might have realized that an isosceles trapezoid has congruent base angles, and you might have used subtraction. You might have done angle D minus this angle to get this angle, angle C minus this angle to get that angle. Perfectly fine. That would be angle, angle, side. I'm just doing it with HL. So if you did it with subtraction of the angles, your proof is probably going to look a little bit different than mine. Okay, so I'm going to pause here and write up the proof so far that I have just to prove these two triangles congruent. Okay, so I wrote up my proof for HL. So you can pause the video and you can take a look at it before I move forward. Remember that if you're using HL, you do need to first state in your proof that your triangles are right triangles because a requirement for using HL is to have right triangles. Okay, the next part is to prove that triangle AEB is an isosceles triangle. So that's that triangle right here in the middle. So I already proved these two triangles congruent. So now by CPCTC, I can say that this side of this triangle and this side of this triangle are also congruent. And now I know this triangle is isosceles because a triangle with two congruent sides is isosceles. I'm just going to add in those two steps. I'm going to pause the video. And there we have the rest of the proof. Definitely make sure to pause the video if you need to, because I'm going to move on to the last question, the next coordinate proof. Okay, so Jim wants to prove this is a rhombus, but not a square. Okay, so -2, 1, 2, 3. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so to make something a square, it needs to be a rhombus and a rectangle. So basically, if it is a rhombus, we're going to prove that it's not a rectangle so that it won't be a square. So rhombus and rectangle make square. If it's a rhombus, but not a rectangle, then it can't be a square, then it's just a rhombus. But remember, before it could be either a rhombus or a rectangle, the very first thing it needs to be is a parallelogram. So you need to pick a property of parallelograms to prove first. So number one is prove quadrilateral math is a parallelogram. So since I know that I'm going to be proving it's a rhombus afterwards, and I know that one property of a rhombus are the congruent sides, I think I'm just going to show it's a parallelogram by showing the opposite sides are congruent, because then I accomplish number one, proving it's a parallelogram, and number two, proving it's a rhombus in one shot. I won't have to redo any calculations. I'm just going to pause the video, and I'm going to find the length using the distance formula of all four sides, because I need both pairs of opposite sides. Okay, so here's my work to prove that the quadrilateral is a parallelogram. And I did show that MA and HT were congruent, those opposite sides. And I also showed that MH and AT were congruent, those opposite sides. And I found out along the way when I was doing all those calculations that all the sides are equal. So that makes it a rhombus right then and there. So my next step was to prove that the parallelogram is also a rhombus. So since I already have all the work for that from my part one, I can just make a new concluding statement to justify that. So I'm going to write, since all the sides are congruent, parallelogram math is also a rhombus. So now, since I don't want it to be a square, I have to show that it's not a rectangle. So we have a couple of ways of showing that we have or don't have a rectangle. Number one is I can find the slope of two sides next to each other, and they should be opposite reciprocals if this is a rectangle. Number two, I can find the length of the diagonals. They should be congruent if this is a rectangle. So I guess let's change it up a bit. I'll find the slopes of the two consecutive sides. So slope of MA, let's get those points. So that is 8 minus 3 over 3 minus negative 2. 5 over 5 is 1. Okay, and now the slope of any side next to it, so I'll just do MH. So that is negative 4 minus 3 over negative 1 minus negative 2. Negative 7. And that's really negative 1 plus 2, so that's 1. So that is negative 7. So there's no clear relationship between the slopes. There's no opposite reciprocals. So that means that the consecutive sides are not perpendicular, so there's no right angle there. So I'm going to write that down. Since MA and MH do not have opposite reciprocal slopes, they are not perpendicular and do not form a right angle. So quadrilateral math is not a rectangle. Remember, if it were to be a rectangle, all four angles should be right angles. They should have opposite reciprocal slopes, any two sides next to each other. So we're almost there. we showed that it's a rhombus, but not a rectangle. So now we just need the concluding statement explaining why it's not a square. So that would be the last part, part 4. Since it is not both a rhombus and rectangle, quadrilateral math is not a square. So just remember a concluding statement for each part that you need to justify your goal. So we needed to prove that it was a parallelogram first, and I had a concluding statement for that. Then that it was a rhombus, and I had a concluding statement for that. Then that it was not a rectangle, so I had work and a concluding statement for that. And then finally, I needed to answer the question and explain why it was not a square, because it was not both a rhombus and a rectangle.